So this is the right arm of a sauropod dinosaur, a long-necked dinosaur called Jobaria. And so if you were to think of this animal as it were alive, you would just bring these bones up like this and then put the upper arm bone on top of it, and you'd have an animal that was pretty tall. My name's Jeff Wilson, and I'm a paleontologist at the University of Michigan. And paleontologists study the history of life, both past and present. And one of the things that I've focused on over the years has been the reptiles of the dinosaur era. Just this February, I went with a team to India. And we went to India with the idea of understanding what India looked like at the end of the dinosaur era. Walking around, looking at the ground as we do as paleontologists, I noticed that there was a little tiny bit of a shell sticking out. It was something that looked like a shell. And realized that it was a shell of a baby turtle. And that baby turtle was still partly in the rock and still partly exposed. So we carefully dug around it with some tools and brought it out. And then we opened it up in the safety of the lab where we have all the tools, all the equipment we need to very carefully clean up the turtle. Our preparator sits with the fossil under a microscope and removes that rock very carefully. And every day I go in and check on the progress.
Hey Bill. Hey Jeff. How's the turtle coming?
So I'm right on the bone here. Oh wow, can I take a look?
Yeah, sure.
That's, wow, really gone deep. You've got part of the leg there. Our turtle, when it gets cleaned up, will go into a museum collection. Here at the University of Michigan, our Museum of Paleontology has a large collection of fossils. So for instance, if I'm studying a snake, I can just go downstairs into our collections, open up a drawer that has fossil snakes of a similar time period in them, take those fossils out, bring them up to my office, and I can study those snakes and the snakes that I've collected side by side. So this fossil snake is interesting because it's an early fossil snake, but it's also interesting because it was preserved caught in the act of eating a hatchling dinosaur. So it was found in a nest with dinosaur eggs next to a dinosaur hatchling, and it was coiled around the eggs and prepared, we think, to eat the hatchling when it was suddenly covered up by sediment very quickly, rapidly, capturing it, freezing it in that paleo instant. When we study a fossil on a fossil site, we're not only interested in the bones and the traces themselves, but we're also interested in the geological context, how it was buried and what it was buried in. And in the case of this ancient snake from India, we can learn a lot just from looking at the sediments. So these sediments tell us that the dinosaur nest was made in the sandy margins of a river, and the plug of sediment that was on top of this seems to have been something that was loosened during a storm where a large clod of debris covered this up very quickly. So fossils like these tell us not only about the organisms themselves, but also about Earth's geologic past. Paleontology involves doing a lot of puzzling, sort of mental puzzling, and even sometimes physical puzzling when we're putting specimens together. And so if you're interested in trying to understand how things got to be the way they are, then paleontology may be the kind of discipline that you should go into.